Hello there, it's Jay here from Jay's Vintage Junk, and today we're working back on with the S4000 control console. I'm actually filming this at the end of what I've been doing because I've realised I was going to make one long video, but the video has ended up so long that I'm splitting it into like either 2 or 3 videos. So basically this video is on making a panel, well mostly, there's a little bit on this monitor which I'm decided to use as the third monitor, but it's basically on making the panel which is going to allow me to connect computers to all 3 of these monitors in various different ways. So we'll get that done in this video, and in the next video we're actually going to get all what I've built actually installed into this into this console, and then in that video we might have a look at putting a computer in here, or that might be a separate video on its own. But anyway, enjoy watching me put this control panel together. Hello there, it's Jay here from Jay's Vintage Junk, and today, well basically this is what I am considering putting in the S4000 command console to replace that other colour monitor. Now, I've played and played and played with that thing. I'm pretty certain there is actually a fault on the horizontal oscillator on the actual monitor. The problem is, without a circuit diagram, I would have to go around testing just every component really in that section of the circuit to try and get that thing working. And it's got other, I think basically, I'm not going to scrap that monitor. I will keep it, and at some point I will do something with it, even if it is just use it for parts. But this is better. What I've got here is actually going to be a much better solution. If you watch my channel for a long time, you've probably actually seen this monitor before. I got a couple of these a few years ago. And what they are, they're military LCD monitors. I believe they were made by Micro VTech of the Cub monitor fame from the BBCs. And I'm not 100% sure how accurate this is or not, but I have heard rumours that these were used in things like Chieftain tanks and stuff like that. Essentially what you've got is you've got a VGA monitor. The panel itself is actually capable of 800 by 600. That's what it was designed for. This is old technology, I will say. This is 1990s LCD technology. So basically what we have is an 800 by 600 LCD TFT screen. But unfortunately, the driver board for it actually only is actually only capable of a resolution of 640 by 480. So it's just, even though the panel is capable of Super VGA resolutions, the actual driver board that's driving it isn't. So it means it's not really a very useful monitor as a VGA monitor, unless you just need a very, very, very basic VGA only monitor. But what they had with them, they were all built into some fancy cases, these things. Very heavy duty, but what they have in them is this board here. Basically what this is, we've got the power supply for the monitor, and we've also got, essentially it can take in composite or RGB video and convert it into a 640 by 480 VGA output, which they can then drive the screen. So I've got this connected up to an Amiga 600 here. It's a little bit dodgy the way I've got it connected up at the moment, because I've literally just got the pins from that lead that I made up just pushed into the connectors from that SCART which I've got connected on. So actually, if I touch that, the picture goes all funny. But it proves it works, and it proves we've got a decent enough image on there to actually use. In fact, I'm quite pleased with the image I'm actually getting off that. And it has another little trick up its sleeve. Like I say, you've got a nice colour RGB signal there. If we take a composite signal, we've got. I will switch the Amiga off, so we're not getting a signal on the RGB there. And if I connect this to the composite and switch on. Now it's only in black and white, unfortunately. It doesn't do a colour composite signal, but it's another black and white composite video monitor. And it's quite a nice composite video monitor, actually, to be honest. Now let's go to something that looks fairly decent. Let's go to breakout. We'll select that. It does if you notice here, it does a reasonable job of actually doing the grayscaling. It's fairly good. Let's start again. Oh, that was reset. Not start. Breakout. No, it's not a bad. It draws nice and quick. It'll certainly do like a dual purpose. So it gives us a nice RGB input, and it gives us another mono composite input. I've got two of these basically. I do have two of these. Unfortunately, I got these as faulty. They were I picked them up on eBay, like I said, quite a few years ago, as faulty spares or repair. And basically, I've managed to build one working unit out of the two. The other one, unfortunately, as far as I am aware, I've tried every other part I can swap over, but I'm beginning to think that Altera chip, which is basically the main processor for the video, is faulty on this one. I've tried swapping the ROM over. That's really all you can do. Backlight and things like that are all working on this, but you don't get a usable image out of it, unfortunately. I have tried the actual LCD panel itself on that driver board, and the LCD panel itself, that works absolutely fine, but the driver board for it is dead, unfortunately. Let's switch the Amiga back on and see if we can get it to it should be able to recognise which input it is, and yeah, there we go. This should boot up, because the hard drive will initiate. This will just boot back up into Workbench now. But it does give us quite a nice clean image, really. It's not bad at all, as you can see. It's certainly usable for what I want in there. Possibly even a tiny little bit more so than that CRT monitor. The great thing with these is they're a lot easier to film. The problem with the CRT is, as you know, unless you get the refresh rate of your monitor synced up with the shutter rate on your camera, you're going to get rolling and flickering, and it doesn't look very good for filming. With this being LCD, and also with the other main monitor in my console being LCD, I thought this would be a much better solution. We still are going to have the green screen CRT, which is a composite input. We're going to keep that in there. I suppose it would have been if I could have got that one working as well. I would actually consider replacing them all and just having 3 LCDs in there. But as I've said, it's at the moment I can't get that one working. I don't think there's going to be any chance of me swapping that Altera chip out. I don't think I'd stand any chance of getting a new one. The reason I think that chip's the actual fault is when you've got it on, if you actually press on that chip, rub your fingers over it, you can actually see it affect the screen. The screen does, various pixels will light up and go off and things like that as you manipulate that chip. That doesn't happen on, well, I'll prove it to you now. With this one here, if I've got to make sure I'm touching that chip and I'm not putting my finger on the inverter board, but if I press on that chip now, as you can see, that's not causing any effect to the actual image at all. As where on the let me make sure this is, I don't want it to fall over and cause any damage, and I don't want some of the stuff I've got in here to short on the on the back of the board. Come on. This is when you regret moving something. There we go. That's staying up again now. So yeah, I'm pretty certain that main Altera chip on the other one is basically. So I'm pretty certain that it's that Altera chip there. On this one is faulty. It's a Altera Flex. I don't know, some kind of CPLD or something like that. I'm guessing so. I'm guessing it's the main processor for this, for like the driver board. It's a shame that how old this is. This doesn't use like the LVDS standard or anything like that, because I was hoping it did actually, because I have like boards like this. This is just a universal LVDS driver board. You can basically configure it to work with various different TFT screens and LED screens, things like that, but it has a standard 30-pin LVDS connector there. This is, I mean, that's 2000s technology. This is 1990s technology, and that connector there is not the LVDS standard. It doesn't give out the same signals, it doesn't give out the same clocks or anything like that. This was really designed to drive these boards in particular. I mean, you can get all the specs for this. I won't say it's a current screen, but you can pick up all the data sheets for these, absolutely no problem at all. The problem is where I'm going to get an interface board that can drive it. If I can find an interface board that would drive that monitor, I would actually possibly consider changing out the green screen one for that as well, because the thing is with these is they are absolutely perfect size. They fit that aperture that's in the actual S4000 absolutely perfectly. But for the moment, like I said, I will stick with the green screen that I've got in there, and I will put this in as the colour monitor. So what I'll do now, I'm not going to bother filming me fiddling about with this too much, but I'll put this back in its case, and I'll actually have a look and see how we can get it into the S4000 and see what it looks like actually connected up in the S4000, see whether it's actually going to work the way we want it to. So back in a sec. Right, okay, as we can see, I've got them all mocked up in the actual cabinet here now. This is the one we've just been looking at, and it fits. I mean, it's not perfect. I did say it was a perfect size. It's not. It's a tiny little bit smaller, but it fits nicely enough. I'm quite pleased with that, really. Then we've got the green screen CRT in the centre there, and then we've got the large LCD there. What we really need to sort out now is how I'm going to interface, other computers and stuff, basically, with these. And with that in mind, I've got this box. Right, I'll just get you zoomed down onto that part of the system. I'll get you over here and I'll zoom you in a bit. The zoom's getting a bit dodgy on this camera now. Right, there we go. So basically I bought that box, and as you can see it's actually a really nice match with the actual colour of the console. Now initially I was thinking about just mounting it basically like that, but what I was thinking I'd do is cut out a little bit of the plastic there and sit that in so it's sat flush with the metalwork there. I've gone off that idea now. If I can help it, I don't want to cut this plastic. So what I'm going to do, I'm actually going to mount it up like that and to that side. That leaves a little hole there. What I'm going to use that for is I'm going to fit some USB ports to a little plate and fit that in there, and that will allow me access to plug a keyboard and mouse into the computer, which I'm actually going to build into the entire console unit. I don't know if to put it on that side or move it over. It might be It might be better on that side and have the keyboard and the mouse actually coming out there, the USB there. In fact, yeah, that would probably work better, thinking about it. Yeah, I might do that. I might have them on that side there. And then basically what I'm planning on doing, I'm going to have a set of buttons on the top there, which will control this monitor. So, you know, for the menu and for selecting the various different inputs and outputs, they're going to be on a set of buttons on the top there. Now we've got a similar set of buttons, but they're actually a panel I'm going to reuse from the screen that we've just been playing with, which I will mount somewhere on the front here. Then basically we've got the rest of that space there and down that side there for the video inputs, so we can have the composite input for that monitor, the end monitor. We can have the composite input for the green screen monitor. We can have the composite input for that monitor all in a line, so we can have comp 1, comp 2, comp 3 like that. Obviously that end monitor has also got RGB on it, so we'll have RGB and sync down there. Then we'll have RGB and sync for that monitor on there as well, so that's monitor 1, monitor 2. This monitor has also got VGA input to it. It's also got component, so we'll get the outputs for the component. We might put them on here because I do have at least one computer which uses component, so that could go on here and we can access the component video. But we've only got the one VGA. Get you up a little bit. We've only got the one VGA input for that, and as I've said, I'm planning on actually building a computer into here. So on eBay, it was only cheap. I picked this thing up. I haven't even unboxed it yet, so we'll do that right now. We'll have a quick look at this thing, because like I said, this is what's going to allow us to have a computer inside it and a VGA input on the side there, just on the one monitor. So we'll take this and we'll take a look at this over on the bench. Okay, so this arrived from eBay a couple of days ago now, but the first chance I've had to actually have a look at it. And this was only dirt cheap, it was under a £5. This is the perfect solution that I can get 2 VGA inputs out of that one monitor. Let me get this open. Hopefully this is going to be in decent condition. It is a smoke alarm with a replaceable battery. No. Obviously recycling boxes here. Let's get in here. Well, it's nice to see that at least we've used some bubble wrap. There we go. Now these certainly didn't cost about a £5 when they were new. If anyone has watched my channel for a long time, they know that I used to work in the AV industry, basically events it was mainly in events management, but I worked in theatre and all sorts, and these were one of our bread and butters, things like this, especially for installations that we used to do. So basically what this is a automatic VGA audio switcher. I'm not too worried about the audio side of it, I'm really not that minded about that, but essentially what we do, we've got 2 VGA inputs there, so that could be, what we used to use these things for was, say, we had a projector connected up with connected up on VGA. We could have 2 laptops connected at the same time, and we were doing like PowerPoint presentations and things like that. We could have one queued up on one VGA input, have something else being set up on the other, and when we needed to, just switch between the 2. It says it's an automatic switcher, but what this thing has, and why I wanted it, is it has a remote on it there. Basically we connect a single pole double throw switch. Is it single pole? 1 pole 2 throws, yeah, to there, It allows you to use that as a remote switch to be able to switch between VGA1 and VGA2 to the output. So one of those can go to the computer, which is going to be built into the console. The other one will go to that little white panel I've just showed on the front, and there'll be a little switch on that white panel. And in fact, I might even use the audio side of it if I'm going to pipe audio through this. Yeah, I might as well. It'll basically allow me to switch between that the video working on the internal computer and the external video input, just with a simple toggle switch on the side of that box. So like I said, these things were very expensive, new. Kramer stuff was top of the range. It was really, really good stuff, Kramer stuff. But obviously this is old hat stuff now, and that was it was just under a £5, which I was really quite pleased with. So I suppose what we're better doing now is there's no point going any further until we can actually sort that box out for the front, which is going to have all our inputs and our outputs and everything on it. Basically what I've been doing, I scrapped a load of old TVs quite recently, and when I scrapped them, I pulled things like these off the back. So there we've got our component video connector from the back of a TV. It's a case of getting these all mounted up so they look nice. I actually want this thing to look fairly decent, so it's all about getting this wired up so all these look really good. But we've got composite video there, we've got component video there, we've got a left-right audio there. I have got a SCART that I salvaged, but I don't know if I'm going. I don't know. What I might do actually is go with BNCs for the RGB and sync and things like that. From the actually off the SCART on the back of the TV in there, I might actually come off with BNCs on the actual box, because that'll look neater. And then I can make a BNC to SCART breakout box that can just be plugged in if I do want to plug SCART leads and things like that into it. That's kind of what I'm thinking. Anyway, I'll get all the bits I've got together and we'll actually have a look at putting this control box together, and then we can look at actually putting all this into the actual console, and we'll basically have it done. So back in a sec. Right, it's time to sort out the box. And basically what I've done is I took the box, put it on a piece of paper, and I drew around it, and I did it about 4 or 5 times actually. And then when I was lying in bed, not being able to sleep, which is fairly normal for me, I took this up in a pen and basically just sketched out where I wanted everything to actually go. So we've got the RGB and the sync for the 2 colour monitors down there, so that's monitor 1 and monitor 3. We've got the VJ on the side there, we've got the switch on the side there to switch between the internal VJ input and the external one, which is that one there. We've got the CYM for the component video up there. We've got composite 1 from the same monitor as that. We've got composite 2, which is the CRT green screen, and then we've got composite 3, which will be the same as the RGB on there. Apart from that, we've got left and right audio in there and there. That is for basically the RGB and the composite there. I'm going to put another 2 audio inputs there, and they're going to go to a separate amplifier. I've not actually done anything with that yet, but I'll put the 2 phonos on there so they're ready to actually use. Then next we've got the monitor controls, so we're going to have 5 buttons across the top of the button there, which is basically going to be for the monitor controls for the monitor 3, the one on the far side. And then we've got some more monitor control buttons here, which are for the monitor 1. Basically I'm not going to bother using new switches because they're all mounted on their own nice little panel, so I'll just drill holes and mount that panel on the front there, because those aren't buttons like these that you're going to need to get to all the time to switch inputs and things. All they are for is setting like the horizontal shift, vertical shift. It's a very nice monitor, and you've got colour correction and all sorts of things on it, so that just gives us access to all them controls basically. You might even have to press them with a pen or something, because they don't stick out very far, the actual buttons, but for what they're going to be used for, just having them easy to access like that, accessible, is going to be absolutely fine. So basically that's the idea. That's basically how I'm planning to lay this thing out. So what we're going to do, we've got the box, and I've got some masking tape. I don't want this to look a mess. I want it to look as neat and professional as I can actually make it. So what I'm going to do, I'm going to take some masking tape, and I'm basically going to cover the front of this and the sides in masking tape. So essentially, wherever we're going to be making holes in the case, we want to cover. Now the idea of this is that we can mark onto the masking tape exactly where we want to drill our holes. And if we get it wrong, we've not left any marks actually on the plastic, so we could always tear it off and do it again if we have to, if we're not completely happy with where our holes are. Right, so that's there. I'm going to put a piece across the back as well, because we're going to be drilling the back of that for the 5 holes. The 5 holes for the monitor control. So we'll cover that over like that. And now all it's a case of doing is I've got a set square here. So we'll draw, make sure we've got that nicely on there, and we'll draw a line down there like that, and then we'll come in and we'll set, say, a particular distance between the 2 lots we want. In fact, we can go to about there. So you get the idea what I'm going to do. Basically, I'm going to draw a grid up on here exactly where all the buttons are going to go on there. So I'll finish off drawing this grid up, and then we'll come right back and I'll show you what we're going to be doing next. So back in a sec. Right, okay, as you can see, I've got basically all what I had on there actually marked on the box now. Across the top, those are the buttons for the menus. I've not done that bit yet. I'll do that bit just after, because I'll have to get the little circuit board out, and we'll have to figure out a way of getting those buttons in exactly the right place so it lines up. But we'll get the rest of these drilled first anyway. What I'm going to use is a step bit like that, and I'm not going to use one of my Makita drills. I've got this. This is actually, this was bought for me in the very late 1990s by my grandmother when I was an apprentice electrician. She actually bought me this back then. I've had this well over 20 years now. I believe it or not, that there is the original battery, and it still works. It still charges perfectly. It's an old NiCad. You still get a good hour's use out of this. Like I say, it's not a powerful drill, it's only 7.2 volt, but it's absolutely brilliant for this kind of work because it doesn't go mega fast. It's got enough power, still got enough torque to do what we want, but it's a little bit more controllable than some drills that you would use for this. So what we'll do is we'll drill these. I've not finished putting my rings around there, just to know which ones I have to drill accurately. And there's a couple of holes like them on the bottom which are just for some securing fixings. They're not as critical. All these have to be a particular size. That's one of the reasons I'm using the step drill, because this should get us the sizes that we need, because we have like phonos like that to come through, but we also need holes for the BNCs for here to go through, and they are slightly different, so hence why I'm using the step bit to do this. I'm going to have to straighten that on there so I can get it through for testing. Right, we'll drill that one there first. So just make sure that we get the step bit bang on the centre of where I there we go, that's through first one, second one. And take that out again, clean it off, and we'll just trial fit the BNC. I think we need to go another size bigger than that yet. There we go, that should be it. There we are, and that will go in. So basically what I've got to do is go through now. Now we know that we've got to go up to that one, we can go a little bit quicker, but we don't want to go too fast. We don't want it to skip a mark anywhere we don't want it to mark. Let's try that again. And once we've drilled the hole again, just want to make sure that it's right. I think I've not quite gone through there. Let me just, there we go. Yeah, that's perfect. So what I will do in fact is I will just go through and I'll get all these holes drilled, and then we'll come back once I've got all the these holes drilled, and we'll have a look at doing that little bit there, and then we can have a look at mounting all this thing up. So back in a sec. Okay, that's all the holes for the BNCs drilled, and these just drop in nicely now. I'm quite pleased with that. I can just go in and they will go in there really, really nicely. What I've got to do now is drill these 6 holes, and these have got to be incredibly accurate, because these basically are going to allow those to poke through like that. So it's going to be just the same, it's just we're going to go for, in fact, let's see, I think we're going to go for the one size under. So let's give this a quick try. This is where I can mess up and make it look a right mess, unfortunately. Right. So the first one. Last one here, and then we can trial fit it and see if it's going to work. Okay, well, let's see if this is going to fit. Well, keep your fingers crossed. Well, I think I'm going to have to go for the one size bigger, unfortunately, on the holes. So it will have to be the same size as the hole for the... But that will work, it'll just give us a little bit of playroom. So let's just try and fit that again. There we go, that's going to work nicely. So basically imagine that coming through from the other side. Yeah, they're going to work nicely. So I've got to do the same there. I'll drill them out. So I'll just go to the centre of the hole. That one. This is the last one. Oops, one. There we go. Right, so let's just quickly check that one's going to fit. So that'll go up there like that. Yeah, and they'll fit in there nicely. Lovely. The only change I have made is I was going to put another audio jack on the front there. I've actually changed it. I'm going to put it on the side there instead. So we'll get this drilled while we're here as well. Okay. Yeah, I mean, that's a lot of plastic. Let's just try to fit this, make sure this is going to work. That's going to fit perfectly. So that'll stick through on that side there. We've got the holes for the buttons on the top. Again, we've got to make sure we've got them the right size because the buttons are slightly different size. These are the buttons that we've got. Just our normal little push buttons. They should work absolutely fine for this. So we need, we have a look. So it's like the second, I think the second in should do us. Let's try that. In fact, we might actually have to go up one side with a standard drill bit just to, it's like it's half and half between what the step drill can do. So what I'll do, I'll go through all these with the step drill and then we'll just open them out with a standard drill bit. Because it's not going to wander or make a mess. We've already got the hole like that, and then we'll flip over and we'll use there we go. And those are now just the right size for those buttons. I think the only things we've got left to do I'll get this back on here because I don't want to lose any of the lock washers. Throw that back in my box. Take that drill bit out and put the step bit back in. We need to put two holes in the bottom. These are just so we can put some mounting hardware to hold this thing in position. So that should be plenty big enough. We don't want to use massive hardware. In fact, I'll go through to the next size because I have got some hardware which will work really nicely at that size, which I know I've got in the corner over there. Okay. So what other holes do we need to drill in this thing? We've got all our inputs there, we've got our inputs there, we've got our inputs there. All we need is to cut out that space there. That's going to be a slightly trickier one, and that's for the VGA connector to drop in there. And once we've actually got that dropped in, we can also mark the other two fixing. In fact, I'm going to have to move. It's a good job I just spotted that. I've got that too close to that mounting point there. I'm going to have to move that up. In fact, I'm going to have to move it up a fair bit. So I'm going to have to move that which I had down there up to about there, or else I'm never going to get the back on it. Yeah, I'm going to have to move that to there. It's a good job I just spotted that, or else I'd have drilled the case wrong. bottom mark. Fortunately with this is we don't have to be mega accurate with it, because this is on the back. And so we'll drill the hole out like that. Unfortunately, when that goes over it, it will cover a lot of the imperfections. It actually won't look bad at all. We need to drill that hole out there. That is for the toggle switch, which is going to and yeah, we have got enough room for that because it's only tiny, the toggle switch. And that will just switch between, like I said, the two VGA inputs. And we need to drill this out. Now what I'll have to do now is just take a knife. Let's see if I can find a knife here now. I think we've got everything we need here to do this next bit. Right, now can you see what I will do? I will extend you up a little bit like that, and then you can see a bit better what I'm doing. So basically what we've got to do now is cut out what's left in there so we can actually drop that VGA connector in. So let's take a Stanley. Fortunately this plastic is reasonably soft. It's softer than I was expecting it to be. He says not being able to get through it with the Stanley knife. Let's see if we can snip through it with these. Yeah. Now, unfortunately, you're probably not going to see what I'm doing because I'm going to have to use the bench like this down on the side. Basically, what I'm going to do is just use the Stanley knife just to pare that hole out to what we need to take the VGA connector. Let's have a look at that now. It's going to need a little bit more. Basically, essentially that's what we're going to do. I'm going to use the Stanley knife and perhaps some files and file that hole out now so that that VGA connector can actually fit neatly in that hole. You can't go too mad at this. You've got to just take a tiny little bit out at once, or else you're going to end up with a hole that's too big for the actual connector. In fact, I will spend probably about another half an hour or something just slowly peeling that away, so I will come back as soon as I've got that connector to fit flush, so back very shortly. Right, okay, there we go. That's took me about 20 minutes or so, so not too bad. As you can see, that now fits nice and flush down in there. It's nice and square with the actual bottom of the case, so when it's mounted like that, that'll work absolutely perfect. We'll actually use two of the proper fixings in there as well, so we can actually screw the cable in place if we want to. So what I'll have to do now is just quickly drill the holes for those to go through. So let's, in fact, we won't use the step drill for that. We will use an actual drill bit, I think. That should be one smaller, I think. Let's have a look what we've got here. I think that should be about right. Probably go one smaller actually. Yeah, that's perfect. So we'll drill those holes. There we go. Right. So really now, oh, actually I've just remembered there are actually a couple more holes we need to drill, because we're not going to get any cables into this. So what I was planning to do on the back here is basically I'm going to cut out say a section like that. I know I've not put any masking tape or anything, but this is on the back. No one's ever going to see this bit. So basically I'm going to cut out a piece like that, and then we're going to put 1, 2, 1, 2, let's put 3, 4, 3, 4, like that, holes in the back. That's basically going to be the main port where all the cables can come in and out, and we'll drill some holes like that so we can actually put some cable ties. When we've got this all in together and mounted up, we can actually loop some cable ties through there and actually secure the cables so they're not going to get yanked or pulled or anything in the future. So we might as well get this done before we go any further. So these aren't critical holes because they are literally just these are just going to be there so we can loop a cable tie through from the other side, tie it tight and just pull, make sure we've got some strain relief for this thing basically. I'm going to drill like that, same here. There we go. Take the Stanley knife and we should be able to cut that bit in the middle away. We've got a nice big cable access way then. See if we can just cut that with ease. There we go. Cut that out. We'll use the Stanley knife just to make that more of a there we go. That's it. As you can see, so we've got somewhere that the cables can go into the back there. We've got a way of securing them once they get in there. So that's it. So I'm going to just shut the camera off, have a little bit of a tidy up on the bench because you can see it's an absolute state now. And then when we come back we'll have a look at actually putting everything into that so we can actually get it ready for wiring up. So back in a sec. Right, okay, that's much better. We can actually see what we're doing now. First thing we need to do is get rid of all this masking tape. Then we can actually have a look at the box, see how we've done. Let's get this tape off. Oh, let's get it. Well, let's not lose that because it's the only one that I've got. We'll take the tape off, and like I said, we'll see exactly how well we've done with the holes. There we go. That's why I like to use the masking tape. As you can see, there's no nasty burrs on any of the holes we've cut. In fact, there's more burrs on those ones that we did with the standard drill bit. Fortunately, it won't matter that. What we're going to do is going to cover that, but it just goes to show, you know, we use the masking tape and the step drill, and the holes look tons better. Let's get that out of the way. Ugh, and all these little bits of plastic which are still dropping out of the box. Right. Now what I was wondering is, do I actually write on, you know, red, green, blue, sync on there? How well does this actually mark? Actually, it doesn't mark bad on the plastic. I wonder if I should actually mark on it what everything is. Right, let's get this thing apart so we can get rid of them last little bits that are inside it, because they're going to annoy me. There we go. Okay, yeah, I'll just get rid of all the little burry bits. Get rid of all them. That's better. Okay, that is more like it. Although I have just seen one thing that's going to cause an issue. I didn't spot that before. Actually, no, perhaps it won't cause an issue. I just noticed there's a little post down there, but I'm hoping it might just be far enough. It's not going to be a problem at all. It's going to miss it. Look. So obviously, like I said, we're going to have the VGA there. That's going to work perfectly. Lovely. So that can go in there. In fact, we can put our buttons in for the top menu as well. Sorry for the screen number. These are all going to be for the screen number 3. Yeah, those are going to work nicely. You can see. So basically, that's what you're going. How you're going to access the menus for that third screen. What we'll do is we'll make sure that we get all the terminals the right same way around, because we've got to common one lot, and then the other lot have a resistor for each one. That's how it uses. It's basically a 2-wire control system using resistors and a analog to digital converter. Get in there. Anyway, this is going to be fiddly. So what I'll do, go in. There we go. Got you this time. What I'll do, I'll get all these fitted in here, all these switches. Yeah, they're going to look really good. It's going to look pretty decent, this. That'll be on like that. Like I said, then we've got our switches to select our menus at the top there. We've got our VJ input there. Let's just quickly try and see if we can fit that that switch on the side for the so this will swap between the two VGA inputs. Which did drill that hole big enough? No, I didn't. I need to go one slightly bigger with that hole there. There we go. Again, hopefully I've just got enough room to get this in with having, yeah, we have, that's lovely. So put that plate behind there, put that in there, hang on, that in there, there we are. Incidentally, this switch I actually salvaged off one of the panels off the microscope, so we are reusing parts of the original actual system, which I quite like the idea of. get that tightened up. There we go. Lovely. So that there will basically switch between, like I said, that input there and the input which is actually going to be the computer built into the console. And that will work through that that Kramer video switcher there. So then basically those three wires there will connect to there on the video switcher, and that's the remote switch for it. So that is perfect. I'm happy with that. What I'm going to do, I'm just going to go and see if I have got any stencils, and if I've got some stencils, I'm actually going to stencil all this up before I'll start sticking all the BNCs and everything through it, because I think that'll probably just make life that little bit easier. Just make sure these BNCs are going to fit as well. Yeah, lovely, they're going to fit nicely. So I've got two different flavours. These again are actually salvaged off the microscope itself, as well. The other ones are some that I had to salvage off some old video processing gear that I scrapped years ago. They're both top quality ones. I think they're AMP actually. I'm not sure what these ones are, but the unit that these came off was a Sony, a commercial Sony video switcher, so they are nice quality. Anyway, Alex, I'm going to go and see if I've got a stencil so I can do something about actually putting a legend on here, and then we'll be right back. Okay, well I found a stencil, and actually I've just been playing on the back here, because obviously this is never going to be seen, and just seeing what the best thing to actually do. And actually permanent marker I don't think is going to work as well as actually a good old fashioned ballpoint pen. Now the permanent marker, yeah, it doesn't smudge straight away, but even with the finest one I've got, I can't get, it doesn't just pop quite like if I actually use a ballpoint pen. The problem with a ballpoint pen is it smudges. What I'm thinking, if I do it now basically and then I leave it overnight, I'm hoping that that will dry off and I should be okay. I could even blow over it with some lacquer after I've put all the on the graphics on before we go any further. So that's what I think I'm going to do. We will do the actual lettering. I'll demo me doing some of the lettering now, so we'll basically get that about sent to where we actually want the. I'm going to do this fairly freehand, to be honest. Yeah, I'm quite happy with the letter placement there. So that's the R we're going to do. So go in with the pen. Basically, let's get in there. Yeah, plenty of ink on. There we are. So that's the R. And I can just go in freehand. And just make the R complete, because obviously we're using a stencil, it doesn't complete the letters. That's our R. Let's do the G, which is a little bit easier. Make sure we're nice and lined up there. Yeah, that's about right. That's our G. And we want our B down there. Again, let's just make sure we get that in about the right place. Oops, I'll move then. I've got to be incredibly careful doing this next bit so that I don't actually rub the R there. We just go in and just join up where we need to join up. And then we want an S there for sync. There we go. So you get an idea. Oops, there we go. There's our RGB and sync down like that. I don't want to touch that until tomorrow when that ink's actually dried. But in fact, what we'll want as well, we'll probably put a 1 and a 3 over there, because that's monitor 1 and monitor 3. We need to put CYM over those, because those are for the component video. We need to put comp or something down here so we can tell what those are. That might be a bit tricky, there's not a lot of room there. We'll figure something out so we can put comp 1, 2 and 3. Then we want an L and an R there for left and right. And I think that should probably actually do us. So I'll come back when we've got all this all finished off. I've got all the graphics written on it like that, and it's dried, and then we can actually, like I said, we can actually start populating this then with all the connectors. Yeah, that's going to look fairly decent. I think it's going to look reasonably professional. Like I don't want this thing to look really amateur and made up. I want it to look a little bit more professional, hence why I'm going to this trouble. So I will finish off lettering all this up, and we can have a quick look at it when I've finished that. Oops, apologies, I forgot to press record on the camera. You've not missed anything majorly. All I've done, I've stuck some masking tape over everything that I'd done there on the lettering, just so it doesn't smudge while I'm messing with the rest of it. And I've actually got that board. That's all you've really missed me doing, is just mounting these up. I mean, those are literally all I had to do, was just line them up there, put a drill bit through the back hole there, mark it, drill the hole and put a screw in just to mount those in position. Same with the left and right audio there. That little panel, like I said, was a little bit more work to do. What I did, I put the masking tape over it, marked on the top of each of them buttons with a permanent marker, turned it over really quick and just pressed it down, and it left imprints where those buttons were, and then I was able to just drill through, and they work really well. They're just proud enough that you can press them with your finger, so I'm really happy with those menu buttons. Like I said, those are for the other screen. So that's pretty much wired up now. What we've got to do, we'll finish off putting these buttons in. So these are for the other, so we've got 2 lots of buttons for 2 of the screens. Obviously the other screen doesn't need buttons because it's just a composite, green screen composite CRT monitor. It's just got a brightness control which is actually mounted on the front of the console. That's one of the ones that's going to stay as it was originally. But for the main monitor on the other side, obviously the buttons that came with it were a bit crappy really. Obviously that being a commercial TV, it's just got a fairly normal button set that you would find inside a TV. Obviously it's not like that nice little panel which was easy to mount to the front for the other monitor. I thought this was a nicer solution basically, and it adds something to the whole theatrics of it, doesn't it? Right, last one of these buttons. That goes on there like that. And that's our, there we are, that's tight enough. So that's our 5 menu buttons for the main screen on the top there. All we've really got to do now actually is add all the BNCs to this. 2, 3, because I've got 2 different flavours here, so I don't want to get them mixed up. I want to use the same for the same. Again, we're going to, let me just, how we're going to do this, I know what we can do. Just use the Stanley knife and we'll just cut out there. What I don't want to do is that I want to leave all that printing really until it's dried properly before it gets touched. I'm a bit concerned about if we touch it too soon it's going to make a mess of it. That's why I stuck the masking tape over for now, just to preserve it, but obviously we do need to get the buttons in, so we'll just take it off from around where we actually want to put the connectors in, like that. There we go. That won't prevent us getting the connectors in now. It's going to be quite a busy little control panel, this. But then again, it's a control panel for 3 monitors with multiple inputs. In fact, I don't think there's going to be much vintage stuff eventually that I'm not going to be able to connect up to this. Because this is only the, I am planning of doing other things with this, with the monitors in here. Right, let's start with these. Yeah, they're going to look pretty good. Put the washer on. Hopefully I've left myself enough room to get all the washers and everything on here. It's the only thing when you're, I mean, I've done that in the past, when I've actually for commercial stuff as well. I've been designing a control panel like to go in there. For instance, I used to do a lot of work for councils, and I've designed installations to go in council chambers and designing boxes like this, and it's looked great on paper and everything's looked alright, and then I've actually come to put the damn thing together and realise I've mucked some spacing up or something, and 2 connectors won't go where they're meant to go, and you can have all kinds of fun. I think this is going to work out okay though. I hope this is going to work out okay after we've gone this far with it anyway. Yeah, I think my spacing is going to be all right. Anyway, I'm not going to bore you with watching me put every single one of them in. So I'll come back as soon as I've actually got all these fitted in, and we can have a look at actually wiring this thing up. So back very shortly. Right. Okay, as you can see, we're pretty much there. I've got all the connectors basically on this now. I've even got that little board for the other monitor, for the menu button for the other monitor, and I'm quite pleased with how that's come out actually. It doesn't look much different than it does on the back of the monitor it's come off. So we've got a menu there, and then we've got plus and minus and contrast and brightness in them controls there, so that's perfect. I very slightly smudged the R there, but it's not bad if you look. It's not bad at all. I'm quite pleased with that. I've got all the buttons on the top, as you saw, all mounted. So basically that's pretty much ready to go now. I'm really pleased with that. The only thing now is I've got to connect that lot to it. Right, what I've done here, basically I've made up cables to come off this to then actually connect into the monitors and the rest of the places they need to go in the console. So what we've got here, well, one of them's not so bad actually because it's just on an easy connect. So we get this one out of the way first. this is that one for that set of menu buttons. So that one actually, I've pre-made these ready to go. So that is the cable for them buttons on the front there. So we've got the connector on that side, and this is cable that I salvaged from the original console from the S4000. So recycling the cable again. So that is basically the first one made, and it's on Molex connectors on both sides. So that one we don't need to do anything with. That'll just plug in when we're ready. Right, let's have a look here now. Now this, basically what I've done, VGA wise, I basically went through my stash, and this has been, you know, cut off a scrap monitor at some point. I have a big box of cables and things that I've chopped off old scrap equipment, scrap monitors, things like that, because they do come in handy. So we've got a VGA cable there, which we can go to the, move this lot out of the way. That will be connected onto that VGA connector there, and like I said, that will then go through the Kramer VGA switcher. So that lot needs wiring to that VGA connector there. And then for the rest of the wires, because to make life easier more than anything else, I wanted to keep it reasonably colour coded. So basically what I did is I stripped down some scrap SCART cables. I had a few which I've kept that, like, one end was damaged on and things like that. And I took the best of them, and basically what I've done is I've stripped out all the cables which aren't needed just for the RGB and sync that I'm going to connect up there. So we've got a SCART on that end which can plug into the back of the monitor in the console, and then to go to here we've got our red, green, blue. We've got a left and right audio, which obviously can go to there, and then we've got our sync on that wire there. So basically that is what's going to plug into the what is monitor number 3, the third monitor that I actually added. That's what's going to get us our RGB, and obviously we'll get the composite off there because it uses the composite for the sync wire on RGB. What we do need is a way of switching the RGB blanking, because obviously that's just going to be then switched pretty much permanently to the RGB signal. So I've run 2 wires out there off the RGB blanking pins. So we've got the blanking signal and the blanking ground there. So we need to give them about 2.5 volts, something just under 3 volts to initiate the RGB switching. So otherwise it would naturally assume it's a composite signal coming in on SCART. You have to put about 2.5 volts or thereabouts on those 2 wires, which will then switch it into its RGB mode. So that I'll basically find I'll have to derive the voltage and then find a feed to power it from, so when the monitor powers up it just automatically connects that and switches it into RGB mode. So that's fairly simple to sort out anyway. So that's the first one made up. Then we've got this long one. Now because it was so long I used the best cable that I had actually for this. But this, and we've got them all tangled up, but we can detangle them. There we go. This basically is for the new monitor that we're fitting, that new LCD. So that's the cable there for the composite input to it, and that's our RGB input to it there. So again, I've basically just made a loom up, and that will simply be connected. Because that's monitor 1, that will go to that one there, and then the SCART one there will go to that one there basically. Then I've made additional wires up for you know, composite 1, composite 2, the composite 3, sorry, that composite 1 is that wire there, composite 2 is one of these, and then composite 3 will be on that wire there, I believe. No, it won't, it'll be on another one, sorry, another one of these that's going into the monitor. So basically that's what I'm going to start doing now, is just getting all this soldered up and connected up. This is probably going to take me some time to do. I've already done the switch one there, that's to go to the remote for the VGA switching, and we need to do the buttons for the monitor there, so that's for the control of the main monitor. Right, we'll start. What shall we start with? We will start with monitor 1, I think, seeing it's the closest to this end here. So what we'll need to do, these will have to go in here. And we'll leave these free for now. Let me get you zoomed out a little bit so you can see a bit more what we're doing. But that's why basically I put these holes in the back. So once these are all in, we can put a cable tie through and just lock them in position so they're not going to get pulled. But we'll leave them free for now while we're actually getting all these soldered into position. We'll get the panel there. We'll move the panel down. Now what I have had to do, these first 4 connectors, in fact the ones that we're going to be connecting these wires to, are actually off the S4000. These ones I salvaged off a piece of old Sony video processing gear that was scrap. Unfortunately they've not got as deep a actual thread on them, so I could only get the locking nut to turn on by about 2.5 turns. So what I've done is I mixed a little bit of rapid set epoxy up, screwed them in, and then just put a little bit of rapid set epoxy over the actual screw heads. I'll just bring it up so you can actually see that there, just like that, just basically just as a reinforcement, because I don't want them obviously coming loose. They weren't pulling off or anything, but I just thought, seeing they were only on, just like I said, just by about 2.5 turns, that means that they're not going to be able to come off. And if I do need to replace one, I can just break the epoxy away. It's not that strong. So let's start with the first wire. Let's start with red, because red's got to go up to the top here. In fact, what we need to do is we need to cut all these wires to the same length. Otherwise, so let's make sure these are all straight. Yeah, they're all straight. I thought one of these was a little bit longer than the others. Let's trim these all so they're about the same length, or at least those ones to about there, like that. We'll start with the red. And we'll just we'll strip. We don't need to strip that much off, actually. That should be enough. There we go. And what we want to do is just twist the screen together. And we can tin the screen up, and then we will tin up the conductor on the end. There we go. Get enough of that exposed that we can tin it up properly. I'll bring the older. Now what I like to do, basically I've got the soldering iron set up like that, and this makes tinning up the wires a little bit easier. So all you need to do is take your wire and just hold the wire and the solder. Just tin your wires up. There we go. That's nicely tinned. If there's any little blobs on it, you can just run it across the iron again like that. Right. And essentially what we need is The conductor wire goes to the centre pin, like that, and then your ground wire goes to the outer pin. Well, there we go, that's the first one connected up. So I've just got another 3 more to do on that, and then so we've got 4, 8, 9, 10, and then we're on to the other connectors over there. So I'm not going to bore you through doing all of these. I will get these soldered up here now, and then we'll move on to the next lot. So back in a sec. Okay, and that's our first RGB connection made there. I've also put that composite, so that's basically the first monitor connected up, because that's only got the two inputs on it, a black and white composite input and the colour RGB input. Right, so let's do the next one, which is going to be monitor 3. Because monitor 2 doesn't have a RGB input, being it's a composite green screen monitor. But this one does. Well, monitor 3 basically is going to be the most versatile of the monitors, being that it's got just about every input you could ever really want on it. And it's the largest of the monitors. Right, so it's going to be exactly the same as I've just done. I'll just do one. So that's a fairly decent length. We're just going to have to just get them about the same length. Let's give them a quick haircut. Like that. We'll start with red. We'll bring them round this way, because I want to keep the wires fairly neat. There we go. Strip the insulation off that. I think these should work just as well. It's a slightly thinner wire on this one. It just depended on the actual scarlet leads. And I was only using up some damaged ones that had an end damage on them. I weren't going to cut up any of my decent quality good ones, but I think that was quite a high quality one that they came out of. But actually the conductors inside are about the same, it's just that the actual insulation's a bit thinner. Right, get this tinned up. Nothing nasty on the end of my soldering iron there. Give that a quick clean. There we go. Re-tin that. We can tin the wire. There we go. Tin that end there. There we are. And we will. In fact, we'd be better off doing the sync wire first, wouldn't we? Which in this instance is the grey wire. If you might have noticed, I actually had to swap the red wire. It was over there, and then I realised I had the thing upside down, so I had to redo it. Fortunately, I'd only done that first one that I'd shown you. Gone round and done all the rest. And I spotted my mistakes, so it was easy enough to correct. Right, again, we'll just get the screen all twisted together. You have to make sure you do get all the screen when you do this, because you don't want one little stray wire to end up there and get twisted in with the actual signal wire, because I've done that in the past and then spent hours trying to find out why the hell I wasn't getting a signal through. So just make sure you've got them all nicely bunched together. Quickly just strip the end of that off. We don't want to expose too much copper, just enough to solder to, really. Okay. Again, we'll just tin up the end. There we go. Now these connectors are actually really intended for PCB mount, but they still work. You've just got to, obviously not quite as easy to solder to as the proper ones that were used over there, but they will work for this. So again, we just need to solder the conductor to the centre there. Then we'll bring the screen down to that next little tab on the side. Rather than it being on the body, it's on a little tab on the side on these. There we go, that's soldered on. You are having to just rely on the solder to hold them, unfortunately, because like I said, they don't have like a little proper solder pot or a hole like these ones do, but it works fine. They're not going to break off, especially not when it's all done. So I'll go ahead and I'll get all the rest of these soldered on. There's only what, 1, 2, 3, 4 more of them, and then we can get onto these audio jacks and the other little bits and bats, which might be a little bit more fun to do. Once they're all done, all we've really got left to do is the big VGA on that side, and then sort the wire out for the monitor there. So back in a sec. Okay, right, I've got the whole of the front panel basically wired now, as you can see. I haven't plugged the ribbon cable that goes in there yet, that's down here. But that's ready to go as well. That'll just feed in through the back and just connect to that there. Just plug in there. Like I said, that's for the other monitor. But all the RGB inputs, the component, the composite inputs, the audio, everything like that on the front panel is now connected up, and I'm reasonably happy with it. All I'm going to have to do now is loom this up a little bit to make it neat, because it's all just flowing out of the back at the moment. But before I do that, because obviously there's going to be more wires to add to this lot, we'll pay attention to the back. And basically there's there's 3 things we need to do in this back section here. One is to put some cables with some phonos on them out the back to connect to whatever amplifier. In fact, I could just put 2 screen cables coming out for the left and right audio there, so that's for future, because I'm going to build a little amplifier or something inside it. So I'll leave those I'll just connect some wires and drop them out. But what we've got is we've got the menu buttons here, which is basically that panel there. So we need to replicate that panel there using those 5 buttons that we installed in the top there. And the way this works is basically it uses a analog to digital converter to allow just 2 wires to operate all these buttons. If you've noticed, we've got resistors on the board here, and essentially what it does is when you switch the switch, it links one of these resistors into circuit between those 2 wires. So when you press that button, it'll probably link that resistor in. When you press that button, it links that resistor in. When you press that button, it'll link, and so on and so on. Or I presume the end one, it doesn't have any resistance at all. And what you've got on the other end is an analog to digital converter, which takes those analog values, converts that into a digital signal, which then the microprocessor in the actual monitor knows. Oh, that means that you've pressed menu button. That means you've pressed volume up button. Dead simple. It's a very simple way of getting all them buttons down 2 wires. There's only one disadvantage with doing that system as opposed to the system like this uses, where it has a line for every signal basically. You can't press 2 buttons at once. The microprocessor isn't, well, the analog to digital converter won't recognise 2 buttons being pressed at once. It'll just come up as an invalid value. Apart from that, I mean, it's a simple, nice way of actually doing it. So it means instead of having all that load of wiring going down to the actual main board, we just use two wires like that. So that needs replicating into there. But before I do that, I'm going to do the bit that I've been really putting off. I've not been looking forward to doing, because I used to do these, in my job, and I hate doing them, which is to solder a VGA connector onto the end of that, so we can connect the Kramer VGA switcher up. So I'll feed this through the back. Like so. Again, this is why I put those all those holes, so we can, when we've got this thing fixed in place, we can put a cable tie like that to actually lock that in place so it doesn't get pulled. But what we're going to have to do bring the wires through like that. At least we can pull this right the way through, and we can have this all out of the way while we actually solder this thing up. We'll get enough of the cable through that we can get this out of our way, and we've just got the cable and the connector to deal with. Yeah, that'll do. That means I can get all this lot out of the way, because we really are getting quite a loom of cable coming off this thing now, if you can see. And obviously we still have some more cables to add to this. This isn't completely finished yet. We'll get that out of the way. We've got this here now, so we've got our red, blue. For some strange reason they've used grey instead of green, but that is basically our green. We've got a horizontal and vertical hold signal. We've got a ground, and I'm not sure what the other, I think it's a sense wire to say yes, there's a monitor plugged in. I have got, I've got it over here, yes. In fact, where has that gone? What I've lost is my pinout for the VGA connector. I did have my pinout printed out to make this life a little bit easier at this moment. So you're just going to have to bear with me while I quickly find out what I've done with it. Okay, well I managed to print out the pinout there, so we're good. I also dug out my little helping hand board. I won't be using the crocodile clips on this one, but the vise is going to be very, very handy, because it does basically hold the connector, which makes soldering it a little bit easier. But first thing we need to do is prep these wires up. I think I will leave them still fairly long, just to make life a bit easier for us. So we'll start. And this is quite a decent high quality cable. It's somewhat thicker than some of the cheaper cables that you get. It does unfortunately mean that it's a little bit on the harder side to actually solder up, but I said your end result's going to be better anyway. Get that twisted up like that. I used to do these in my job, because we used to do some AV installation work, and sometimes you can't always rely on cables being the right length, or you might have to have a cable where you have to go through a wall or something with it, and not have to drill a great big hole to get a full DB9 connector through. So you drill a hole, pass the cable through, and then remake the connector on the other end. In fact, I've done this for a projector about 25-30 foot up on the top of a ladder, and soldered one of these together many years ago. I wouldn't do anything like that now, but I have done it in the past. But right, what we need to do, this is a salvaged connector. In fact, I'll just spin it round just to make my life a little bit easier. This is a salvaged connector, but that won't matter. It just means basically it's pre-tinned. But we will add a little bit of fresh solder to the points anyway. don't think we need them ones. Right, so, and we've got separate, we'll keep all the grounds separate as well. In fact, what I will do, I will strip all these first, and then we will go to connecting them, and then we're not pulling on a cable by mistake. In fact, you've just seen me strip one of these, so what I'll do is I'll pause the video, I'll come back when I've got all these stripped and prepped and we're ready to start soldering them onto the connectors, because like I said, this is already going to be a mammothly long video anyway, so back in a sec. Okay, I've got all my ends stripped there, so it's just now going to be a case of just tinning all these ends up so they're ready to solder into position. So see, like you saw me do on the other one, basically just I'm holding the wire, so I've got the soldering iron on the stand, and doing it this way just makes it that little bit. I'm just going to strip a little bit more on that one. I haven't quite stripped enough of the insulation away. There we go. So I'm keeping the iron basically on its on that little stand there, and then bringing the wire into the molten solder on the tip of the soldering iron, adding a little bit of extra solder. In fact, if you really want to, you can add a little bit of liquid flux to the wire just before you tin it up, and it just helps it the solder to flow. I'm getting away with it on this instance, but if it wasn't soldering very well, that's basically what I would do. I'd just add a little bit of liquid flux to the wire before I tinned it. There we go, that's all the screened wire, so that's our RGB. So then we've just got these four here, three of which I think we need, and one I'm not sure about. I'll figure out what it is anyway, and we can know whether we're going to connect it or not. Right, so just quickly tin these up. That a bit. If anyone can hear anything in the background, I do apologise, but we seem to have one of the worst storms we've had in England, in the northwest of England, for a while. Fortunately, I've not had any damage so far, fingers crossed, but I know some damage has occurred in the village. Well, not in the village, in the just down the road in the local town. I've seen at least one wall come over and flatten someone's car. Right, so we're about there now. So that's the first one we want to do, which is red. So I've already tinned up the socket, and I say this was a salvage socket anyway, so it already did have some solder on it. We'll try connecting the ground first. Okay, that connected okay. And then hopefully we've left enough. Oh, I've not. Could do with getting that a bit further down there. There we go. So these pins are hollow, so basically you want to push the wire down into the hollow of the pin. That's not very good. We're going to get that one back off. Let's add a little bit of fresh solder to that actually. There we go. Let's just tidy the end of that up. There we go. There we go. Right, okay, let's try that again. I certainly would not be able to do this dangling off the top of a ladder anymore, I'm certain of that. Let's have a look there. Okay, that's the first one connected. Yeah, that's neat enough. Let's just hold that so it holds that tight. Now we have our grain next. In fact, that just needs trimming down a little touch. We don't want that really much longer than that one. Let's take the end off that. I don't know why they've ended up with grey as the green wire. It won't really matter, fortunately. The electricity can't see colours. Just to think I used to be able to do this without glasses on as well. I think we got it there. These are incredibly fiddly to solder. Okay, that's the first two done. So that's red and green, so we've got the blue to do next. So basically the grounds go to pins 6, 7 and 8, and the red, green and blue go to 1, 2 and 3 on this connector. Now I'll do a little bit of extra solder to that. There we go. The ground connected, and we'll go in and connect the signal wire. There we go. Oh no, it wasn't right then. It's incredibly tricky to do this. It is for me now. It wasn't many years ago, but it is now. Okay. So that's our RGB connected. Now what we need to find out is which one's the H sync, which is the V sync, and then I just identify what the other two wires are. Now the black wire I'm pretty sure is going to be V sync ground, but the others I am not so sure about. And what we will do is we will use the end of the VGA cable here to actually figure out what wire is what. Let's spin that back round. So that's our RG and B connected there. I'm quite happy with those. They're reasonably well connected. Now on this side we've got, that's obviously missing the end pin because the end pin there isn't used. Our next two pins, our 13 and 14, are our horizontal and vertical sync. So what I'm going to do, I've got my continuity tester here. I'll connect the first of those pins, which is going to be pin 14, which is vertical sync. And then, so I'm touching the vertical sync pin. Okay, there we go. So yellow is vertical sync, so we can get that connected. There we go, that's connected. Now we want to find, oh no, I've connected that to the wrong bloody pin. I've connected that to the pin 15, it should be connected to pin 14, damn. So we'll move that over, pin 14. Okay, that's it, we've got it. A little bit tricky to get it to solder then, but it has gone in. Right, so next we want our horizontal sync. And that is going to be on pin 13, which is here. So we'll connect to pin 13, hold on pin 13. There we go, let's get back on pin 13 there, and we'll try that. There we go, it's the white wire. Oops. And there we go, that one's connected. So that's our horizontal and our vertical connected. Excuse me. Now we want to connect, we've got 2 wires left. Now let's try and find out which ones these are. So, start with the black one. I'm guessing this is going to be a ground wire. That's pin 4 on there. That's a reserved pin, so I don't think we're actually going to need that. And then we just need to find out what this wire here is. Now I'm guessing this is going to be a ground. And it is indeed, that's the ground, so that goes to pin 5. So we'll take that. In fact, we can connect that other one to pin 4 because now we know which wire it actually goes to. I don't think it'll cause any... Ow! I just touched the end of the solid now with my finger then. Right. So the black wire, seeing we know where it goes, I don't think it's going to really do anything because like I said, it says reserved. But we will connect it. There we go. And the next wire, the final wire there, is the ground, which is going to go to pin 5. And there we go. And that's connected. So there we go. See, I've not done that for a few years. That's not too bad. We don't seem to have anything shorted in there. That looks pretty happy. A little bit of actually, there's a little bit of solder there. So let's see if I can remove. I don't think it'll cause any problem, but there we go. It was just a little bit of solder that had come free, but there we are. So that's that in. Just move the soldering iron out of the way for a second. So that we can push back through. And what I might actually do is put a cable tie just to hold that there for now. Because we're going to have to do something with that extra wire there, aren't we? We'll pull it through for now. We'll probably have to put in fact we'll pull it through and then we'll put a cable tie on there to hold it. So I don't want them wires getting yanked now I've done all that faffing about. And I've got the connector the wrong way around. Just let me just rotate the connector around. I have to turn the whole thing because like I said this is quite a thick, decent quality cable. I didn't use anything too rubbish for that. Right, that's going to work if I put a cable tie on there. So we'll take a cable tie. We'll go through the hole that I made. Oops. Make sure we get all the wires though. Go through the hole that I made. Come back up like that. Yeah, that'll work nicely. Some strain and relief for those cables. But what we'll do is we'll fix that in place there first, and then we will look at screwing that in place. I need some nuts to go on the other side of them. Which I think I'm going to pinch off this scrap here, because those should be the correct ones there. I've got a better pair of pliers to get them off. Yeah. This is called not planning ahead. I spotted these and thought, oh, they'll do to secure the other side of the nuts there, and then I forgot to take them off the board. I think this is definitely going to be a two-parter now. I was planning to do this as one final video for this system, but this video is already going to be ridiculously long, so it's definitely going to be part one of two. Right, let's just make sure that these are indeed going to work out for us. I think they will. They've even got some thread locking kind of compound on them. I think they're the right thread pitch for them. Let's just hold that in there and see if that will spin on. Oh, that's a no. I've just snapped the damn thing. Damn it. I think you're going to have to bear with me a second, folks, because that isn't going to work. I do have some other... I'll have to find a replacement for that now, because I've just snapped the end off it. Let's try these. They should work. Right, put that through there. Let's see if we can get this to screw on the other end. Yeah, that'll work. Okay, that's going to work. That holds that. So we're going to need another one for there, and then we can tighten that cable down there, and that'll hold all that in place. Right, so where am I going to find another of them? I'm going to be naughty, just pinch one off the compact computer, which I've still got sat underneath my desk. I have got a little pot of those these securing bits, so it's not a problem. It's just quicker for me to pinch one like that for now, and I'll replace it after. Right, okay, let's stick that in there. Oops. There we go, got it. Just get that with some pliers. There we are. Okay, so that's the VGA connector held in place. We'll just get these cables where I'm happy with them and tie them down. I don't want those to get yanked, and of all the cables in there, like I said, that's the one that I really didn't want to have to do. I hate doing them. I think we've got away with it. It looks pretty decent. That I don't think we've got any shorts or anything, so happy there. Snip that off. Right. I suppose the only thing we really need to do now is connect these switches up. Let's get the wire. We might as well reuse this wire. And let's see how this works. So we've got the first switch there. We've got a common rail basically down one side, with one side of this connected to it. Then we've got the switch. Right, got going through the first resistor. So the first switch doesn't have a resistor. The second switch has a resistor. Yeah, that's that resistor. That goes through there, and then that switch has... What I'll do, just bear with me a second, I'm just going to pause the video and just draw this out so I'm absolutely sure I know how this thing's been set up, so back in a sec. Okay, so this thing really is very, very simple. Let me get you zoomed out so you can basically see what I've just been scribbling. Oops. Let's get you down on the paper. Right, basically this is it. As you can see, so basically we've got a common up there, we've got all the switches across there. Then we've got another line here, so basically when we switch that switch it's as though we'd shorted both wires together. Then we've got a resistor, then the next switch, so when we switch that switch it's got to go through that one resistor and back, and again the next switch, when we switch that switch it's got to go back through those two resistors and back. Next switch through those three resistors and back, next switch through those four, so that basically each time it's adding the resistances together, which is giving us that analog value that goes into the A to D to analog to digital converter, which obviously gives us our signal to the microprocessor. So yeah, it works really well. So all we need to do is pop them resistors off there, put them along there, and it'll work. So what I'm going to do, let's bring this back in. Now this wire here is basically that common wire. So what I'm going to do, I'm going to tin that whole wire up, and I'm going to solder it all the way across. In fact, I'm going to thread this through the back of the case, so so it's in with everything else. Like that. Now we need to strip off as much of that, so it's going to be able to basically go all the way along there. So that should be about enough. Get that stripped off. Just cut the end off to make it easier to strip. There we go. We'll twist all this up and then we can tin it. Hoping that the legs on those resistors are just going to be long enough to allow this to work. If not, we'll have to find out what value all those resistors are and replace them. They should be fairly standard values anyway. Right, okay. Let's get this tinned up and we can get this soldered into position. There we go. Just run that back on there, get any excess off. Right, there we go. So that's basically our common. It's going to go all the way along all the bottom of these connectors there. So in fact we should be able to trim a bit off that. It's a little on the long side, but it will work. Okay, we'll get that into a position where we're not going to melt anything while we do this. Which way do we want these buttons to go? Right, I think we'll go that way with them. Clean the iron off. We want to tin basically all these solder points up. Try not to dwell on the terminals longer than you have to with these cheap momentary switches, because you can actually damage the switch. Not the best things in the world. Try and be as quick as you can. Nice hot iron. That's what I like to do anyway. Okay, there we go. So those are all tinned up. We'll take our wire now. Get this in position. We can start soldering it in place. Okay, I'm happy with that there. Okay. Just anchor it in a couple of places to start with. Right, there we go. And I can get that and just pull it into place where I want it. Then we can cut the excess off when we've finished. There we go. I'll probably just tack that end there. Oh, I've gone underneath one. Oh, it'll be alright. It started coming down again. We've had hail, sleet. No snow this side yet. I think Buxton's had quite a bit of snow, and it's on the hills. When you look over the hills you can see the snow on the hills, but where I am we've not actually been hit by any snow yet. I'm guessing the camera's picking up that hail noise anyway. There we go. Okay, I'm happy with that. So that's the first one connected. We can snip the excess off there now, like that. Get that out of the way. I've got a melted bit of solder into the bottom of there we are. Get that off. Off you come. There you go. And you. Right. So next we've got to start removing these resistors from here and adding them to that. So let's take this first resistor off. I'm hoping these, when I've straightened the legs out, might just be long enough. In fact, this first one we could actually cheat, couldn't we? We could, yeah, we could. We're going to need a bit of leg. So I'll strip some of that off. I should have really stripped this before I soldered that other bit in position, to be honest, but we'll get away with it. Come on. There we go. I'll twist that up. And I'm going to pass that through the eyelet. I know on the other ones I didn't, I just laid it on and soldered it on, but which isn't really the way to do it. You should make a mechanical connection, as I always say when I'm doing my anything with valve stuff, but in this instance I think I'm pretty happy I'll get away with it. Right, I'm just going to put that through there, because if I need any extra length I can just use that bit of wire to give us some extra length. Let's pull the first of these resistors out of here if we can. So if these are no good, we could always bloody lead-free solder. Damn, they're done. Let's add some proper good old-fashioned leaded solder to that. See if we can get these this solder to flow. There we go. Yeah, I can just push the resistor out now. There we go. That's the first resistor out. It might still be a bit warm, but let us see if we're going to get away with reusing these. I think it's just going to be long enough to do this. Yeah, lovely. So what we'll do is we'll solder that in place there. Okay. That's alright, we'll have to snip that excess off there. Like that. Pull the next resistor off the board, which is that resistor there. Hopefully this is going to be long enough as well. That's some nice full fat leaded solder to it. There we go, let's drop straight out. And we should straighten that resistor out now. I drop that in there like that, bend it down. I should be able to solder those. So essentially we're doing exactly what that circuit board is, just point to point. There we go. Let that move, but that doesn't matter, we can bend it back into position. Stick you. Bend the end of it, get that in there, like that. I will just quickly pause the camera and I'll just do these last two off camera. Otherwise this video is going to be far too long, so we're back in a sec. Okay, and there we go. As you can see, we've got all the resistors now in place. I did take the liberty while it was off just to solder that extra wire on there to this audio output, so we've got just a stereo, well, left and right channel basically run out of the back. Like I say, that's to go to another amplifier I'm going to build into the console. But the most important thing now, that is everything basically in the front. We'll get the cable which goes for the other monitor. We will feed that. This is getting very cramped now. Perhaps I could have possibly done with a slightly bigger hole here, but I think it's just going to be enough. Let's push all them wires to that side while we feed this through. I think there's just going to be enough room to do this. Everyone breathe in. There we go. We'll bring that through like that. Try not to snatch that wire back. bring all that through for a minute. There we go. And that needs to connect onto there. Oops, that's the wrong way. Is that the wrong way around? It'd be that way around. Yes, indeed, it should have been that way around. So let's get that to plug into there. Is that plugged in? There we go. Right. So this is the moment of truth. Is all this going to fit? So we'll pull the excess wire back through. There's a pink and a orange wire there that need to be pulled back through. Them two. Okay. Now we've got that wire that can be pulled back through. That's the remote wire for the that's the remote wire for the monitors. Right, so basically what I want to do is ease all this lot, everything that's currently too long, back through here. There we go. There we are. Is it going to? Look at that. I'm going to stick a couple of screws in this just to hold it for the time being. Oops. Okay, and yes, let's put all 4 screws in, actually make sure it does actually fit together properly. There we are. Let's get them screwed down. There we are. That's it. Right, we'll get this lot of cables to hang down because I don't want them to get all tangled. I'll have to make sure that these are kept really neat and tidy, actually, because what we don't want now is a big mess of cables. There we are. I've got the VGA cable tangled up in with the SCART cable. There we go, that's detangled now. So basically that's it. We've got our basically our control box, which is going to go on the front of the S4000 and allow us to interface with the 3 monitors which we're going to have, which are built into it. I am really pleased with how that's actually come out looks wise. Doesn't look too amateurish anyway. See, everything's marked up the way I need it to be. I've got plenty of cable, as you can see, coming out as the loom. So all this will go to various things inside the S4000. But that is going to be in the next video, because this video is already going to be ridiculously long. I like my videos perhaps to be an hour tops. An hour and 10 minutes, an hour and a half is a long one. I think I've not edited this up yet, stuck it all together, but I have a feeling this is going to be a very long video. But anyway, that is a lot of work done. Like I said, that is all now ready to be installed in the S4000, which is what we will be doing in the next video. And then we can finally actually get this project buttoned up and finished off. Anyway, I'm going to leave it there for now. I hope you enjoyed watching me put this thing together. So thanks for watching and goodbye.